$10 trillion. That number moves every single day through banks, through hospitals, through stock exchanges, through airline reservation systems, through the Social Security payments of over 60 million Americans. And almost none of it runs on Windows. None of it runs on Mac OS. Most of it doesn't even run on Linux. It runs on an operating system that was first deployed in 1966. An OS so old, so obscure, and so deeply embedded in the fabric of global finance that most software engineers alive today have never seen it, never studied it, and have absolutely no idea how it works. This is IBM z/OS. And if you've never heard of it, that's exactly the problem. When you walk up to an ATM, you see a screen, a keypad, a slot. What you don't see is the chain of systems processing your request in under 2 seconds. Your card number hits a network, that network pings your bank's core system checks your balance, authorizes the transaction, and sends the approval, all before you've finished reading the screen. That core system, in the vast majority of the world's banks, it's running on a mainframe, running z/OS. 95 of the top 100 banks in the world, 10 of the top 10 insurance companies, 23 of the 25 largest retailers in the US, all 10 of the world's top airlines. z/OS. Not a cloud, not a server farm in Virginia, a physical machine the size of a refrigerator in a data center you've never heard of, running software that predates the moon landing. In 1964, IBM released the System 360. It was the first computer architecture designed to handle both scientific calculations and business transactions on the same machine. Before this, companies needed different computers for different tasks. IBM changed that. One machine, one architecture, everything. The OS that ran it was called OS 360. Over the decades, it evolved: MVS, MVS-XA, OS 390, and eventually z/OS. But here's the critical thing to understand. It never stopped being backwards compatible. Code written for OS 360 in 1965 will still compile and run on a modern z/OS system today without modification. That's not a feature. That's a trap. A very expensive, very comfortable trap that the entire global financial system fell into and has been unable to climb out of for 60 years. The latest IBM mainframe, the Z16, costs between $4 and $8 million. A fully configured enterprise setup, the kind of major bank runs, can hit $30 million. And they're still selling them. IBM's mainframe business generates over $3 billion a year. Because once you're in, you don't leave. So why hasn't anyone replaced it? 3 reasons, and each one is worse than the last. Trap 1. The cost. In 2018, TSB Bank in the UK decided they were done with their legacy mainframe system. They spent 2 years planning the migration, hundreds of millions of pounds, teams of engineers. On migration weekend, 1.9 million customers were locked out of their accounts. People couldn't pay their rent, couldn't access their wages, couldn't make mortgage payments. The outage lasted weeks, not hours, weeks. The CEO resigned, the regulatory fines hit £48 million. The total cost of the failed migration, over £330 million. TSB is not an outlier. It is the rule. Every major bank that has tried to migrate off a mainframe in the last 30 years has either failed, massively overspent, or quietly decided mid-project to keep the mainframe and build around it instead. Trap 2. The code. If you watched my previous video on COBOL, and if you haven't, the link is up here, you already know part of the story. z/OS doesn't just run alongside COBOL. z/OS is what COBOL runs on. There are an estimated 95 billion lines of COBOL still in production globally, processing transactions, managing records, calculating payroll. You cannot swap the operating system without rewriting the code.
You cannot rewrite the code without understanding the business logic embedded in it, logic that was documented in the 1970s in binders that no longer exist by people who are no longer alive. So you're not just replacing an OS, you're re-engineering 60 years of institutional memory that was never written down. Trap 3, and this is the one that seals it. ZOS is extraordinarily reliable. IBM mainframes are rated for 99.9999% uptime, 6 nines. That's 31 seconds of potential downtime per year. AWS, Amazon's cloud, had 14 major outages in 2023. Azure had over 20. Google Cloud had multiple. The mainframe? Almost nothing. When you are a bank processing 400 million transactions a day, 31 seconds of downtime per year is not an engineering achievement, it is a moral requirement. And ZOS delivers it consistently, every year. So you have a system that costs a fortune to replace, that has 60 years of irreplaceable code running on top of it, and that works better than anything built to replace it. What would you do? You'd keep it. Everyone keeps it. That's the trap. Now, here is where it gets genuinely alarming. A machine can be maintained indefinitely. You can replace parts, you can upgrade firmware, you can keep the hardware running as long as the manufacturer supports it. But you cannot replace the human knowledge required to operate it. There are approximately 20,000 trained ZOS professionals left in the world for an operating system that the entire global financial system depends on. 20,000 people. The average age of a mainframe professional is now estimated to be in the late 50s. Some surveys put it over 60. IBM tried to address this. They launched the IBM Z Academic Initiative, a program to get universities teaching mainframe skills again. As of today, around 1,000 universities in 70 countries have signed on. It is not enough. The rate at which experienced mainframe engineers are retiring out of the building outpaces the rate at which new ones are being trained by a significant margin. And this creates a problem that money cannot easily solve. You can pay a retiring ZOS engineer a consulting fee to stay on 2 more years. You can document their knowledge, if they have time, if they can articulate what has become second nature to them over 4 decades. But you cannot transfer 60 years of intuition. You cannot transfer the knowledge of someone who was there when the system was built, who understands not just what it does, but why specific decisions were made in 1974 that are now embedded in production code that nobody is allowed to touch. There's a term in the industry for this. It's called tribal knowledge, and it is walking out of the building every day, one retirement at a time. Let me show you what old, unmaintained critical infrastructure fails like, not mainframe failure specifically, but the closest analogies we have. August 2003. A software bug in an energy management system in Ohio, old code, undermaintained, never fully tested, triggered a cascade failure across the northeastern United States and Canada. 55 million people lost power. The outage lasted up to 4 days in some areas. Estimated economic damage, $6 billion. August 2012, Knight Capital Group, a major U.S. trading firm, deployed a software update. An old, deactivated piece of trading code, something that should have been removed years earlier, got accidentally reactivated. In 45 minutes, the firm lost $440 million. They were bankrupt within days. December 2022, Southwest Airlines' crew scheduling system, built on legacy infrastructure that hadn't been modernized, collapsed under the load of a winter storm. While other airlines recovered in hours, Southwest took 10 days. 2 million passengers stranded, 16,700 flights canceled. Fine from the U.S. government, $140 million. None of these were ZOS failures, but every single one was caused by the same thing: old, critical infrastructure that organizations had chosen not to modernize, either because it was too expensive, too complex, or too risky, until the day it wasn't a choice anymore. Now apply that logic to the system processing your mortgage, your pension, your hospital records, your ATM withdrawal. ZOS has never had a catastrophic failure at scale. But the conditions that produce catastrophic failure, aging infrastructure, knowledge drain, underinvestment, no viable alternative, are already in place. The question is not whether something will eventually go wrong. The question is whether anyone will be left who knows how to fix it. Here is the paradox of ZOS. The most reliable computer system ever built is also the most fragile, not because the machine is fragile, but because the knowledge required to keep it running lives inside a shrinking group of human beings who are getting older every year. The mainframe will outlast them. The knowledge may not. And somewhere between those two facts is the quiet risk that nobody at your bank, nobody at your hospital, nobody at the stock exchange wants to talk about in public. This is one layer of the infrastructure running the world. There are others. Subscribe because we're going deeper.